Welcome, everyone. As Larissa pointed out, I'm Lin Chear. I'm a senior software engineer here at Achievers. Just a little bit of bookkeeping notes. Some of the demos that we were walking through has been optimized for OS X. So if you're working along with a Windows laptop, you might have to find equivalents to that too. Most part, everything works with Bash, but there are some discrepancies on how it's volume mounted. So please take note. If you have any questions about that, just see me afterwards. So I'm going to talk a little bit about Symfony and Docker and how we use that in microservices. Just a show of hands, who here uses Docker at their work right now? Yeah. Cool, yeah. Good to see those hands up. How about Symfony? Who here uses Symfony? Oh. Thank you for raising your hands for that. I'm going to clear the elephant in the room first. I got that shirt from Old Navy, so if you want to go get it yourself, $19.99. My wife would be proud. So what motivated us to go towards this path? I will take you on a trip about 1.5 years ago. It started off with the current state of our market right now at Achievers. We work on rewards and recognition software. We came in, we disrupted that market, and we did a great job at that. However, upon the horizon, there's a new market called the employee engagement market that's coming up. We decided we got to get in there. We got to disrupt that market too, mostly because that market doesn't quite exist yet. Let's create it if it doesn't. So we drew up a plan on how we're going to go about doing this. We developed a piece of software that sits in our current platform. So our current platform right now is that thing that I drew out in the top corner. It's a news feed that shows what's happening in the company, what people are doing. What we needed to do is create some way for them to engage with their employer. And in our case, we're going to create a chatbot. It's a great way for people to just type their comments into something that was friendly and very user-intuitive. Everyone knows what a chatbot, right? Who doesn't know? Raise your hands. Yeah, no one raised their hands. So we decided that we're going to build this out. How we're going to do that, we didn't quite yet know, but we ended up creating a prototype of it. And this is our software right now. It's that little happy face there. You click on it, you kind of tell what your manager, like what you're feeling about work today. I'm feeling great about my job today. I just got a promotion. Cool. What should I do? More money, obviously. My manager's in the audience. He's reading this. I love you, John. So that was our software. We ended up taking it from that sketch in our brains to this prototype to actually getting paying customers, giving us cold, hard cash for it, something that didn't exist in a brand new market. Someone's paying for it. And that is the actual photo we told the customer to give us. It's a little bit more than $3, but you get the point. So having said that, there were some strict requirements that we had when we were developing this software. Number one, it's a brand new product. We couldn't really use any of our old code base or extend our old code base simply because we didn't have anything at the time. It's a brand new market. It's something that a lot of people are trying to go towards, but they don't have it right, and I think we have it right. So we're building a new product in a new market that hopefully will disrupt the market. We also had minimal infrastructure because management said, we got to disrupt the market, we got to build this. Where are our servers? We asked, figure it out. So we got minimal infrastructure. We had to figure out how to go about doing that. And the most important thing is it had to have no impact in our core business. We had to deploy this with the existing product, but not impact anything. We can't take down servers to put this experimental software up. So having those requirements, we decided what are we going to use to build this? Top of mind, we are a PHP company, so most of our stack is written in PHP currently. We explored a lot, but we settled on Symfony. Symfony is a PHP framework. Framework pretty much helps you organize and develop and deploy software in an organized manner. We approached looking how to deploy, and Docker seemed to be the technology that would help us. What is Docker? Most people, who doesn't know what Docker is? Okay, everyone knows what Docker is. It's container technology, and it helps us build and deploy applications. And finally, we went towards a microservice-ish approach. If you look on the web and you type, what is microservice, like I did about like a half a year ago, 1.5 years ago, there's really no consensus. You kind of get like, well, it's kind of this and kind of that. But what we took from that was that a microservice has to have discrete functionality. It has to be loosely coupled with the rest of your services. And it has to be independently developed and deployed from the rest of your service. So that's the key points that we got from that. We're talking about why Symfony. You could go to the website, figure out why Symfony, but the reason why is developers, developers, developers. We have a whole bunch of PHP developers. We can pick and choose the best from everywhere, so maybe all over the place, and bring them into our team. So we had a pool of developers already. It's a proven framework. It's used quite widely in the industry. There's active development in it. When we started, it was 2.8, and then it moved to 3.4. Now it's 4.1. Big improvements along the way. And it's widely used. Big factor to that is Stack Overflow. If you ever have a problem, Google it. Stack Overflow will teach you everything. Everything. It's based on Composer. So Composer is a package management software for PHP. It helps you manage the bundle. So it allows us to pick and choose packages. It's easily extensible. Having worked with it, you can do all sorts of things with it right from the get-go. There's great documentation. In their documentation, they say they're database agnostic. So they say, well, here's the core packages. You don't actually have to have a database. It's not integrated into it. But if you wanted to, you can use Dockerizing, what we use. And it's shallow learning curve based off of PHP. It's got tons of documentation, great community. And someone asked, is it free? I say, yes, it's open source. So you can go ahead, clone it, use it without paying licensing. So why Docker and microservices? Here's a relevant XKCD. We're not going to read the whole thing. But basically, yeah, this guy has like, he wants to build software with 2 pieces of websites, kind of glue them together. In the end, he containerizes it by gluing 2 iPhones together. It's fairly clever. And then why Docker? Everyone uses it. Everyone knows about it. When I asked if you didn't know, everyone just kept their hands closed, so everyone knows about it. It's container technology. Container technology helps you bundle your code and your dependencies all together. It helps simplify deployments. Deploying containers is quite simple. I'll show that a little later. It works on a build once and deploy many philosophy. And for our purposes, it's minimal impact, meaning we could use everything above and not have to impact our core business. And that means independent deployments. You can just deploy containers independently of your main package. So let's talk about how we traditionally build and deploy software in the old world. Everyone kind of recognizes this in the PHP world, where you work on your source code on the left-hand side. It goes through a build process. You might have an artifact of some sort, like a tarball or whatnot, a zip. It gets through a deploy process, and these are your servers. Be it virtualized or whatnot, they get put onto the server. The artifact gets on there. And there's probably an app server and libraries in the server itself. So there's a couple of pitfalls to that. One, what if you are developing on your local, on your OS 10, and you installed independently, okay, I'll install Apache, I'll install MySQL and whatnot, and this library, PHP Memcache, all these other things. And then you go to deploy and like, oh, I didn't tell the DevOps guys that I needed a certain library. Everything will fail because of that. So if you're not careful with all the dependencies on your side as a developer, things can fall flat on that side. That means that different services even will need different dependencies, because unless you create a big service with everything in it, every library that you could possibly need, you'll probably have to provision it uniquely per service. And because of that, it's quite hard to scale. Like, okay, I need a service up for my user service. All right, we'll create a, I don't know, a macro or a shell, like chef or whatever, to create that. It becomes a bit of a management nightmare when you offload that. So, containers to the rescue. What does that mean in our current world right now? On our left side, we build everything with the source, and as developers, we define the dependencies ourselves. We define the app servers, the libraries, and it's running on a container engine. That's all that is needed to run it. So in our case, the container engine is Docker. We build it, out comes an artifact. In this case, it's the container. The container contains all those top three on the other side. And when you deploy it, you deploy your dependencies on your machine right there. And the container itself runs on the container engine, pretty much the same engine on both sides. So what does that mean practically? It means that you can have all sorts of disparate services, different services, and you can deploy them on each of those stacks over there. All you have to worry about is, as long as the container engine is the same as, like you're using Docker, you can deploy it. All your dependencies will be spread across there. You'll have the right dependencies in each container. So that's the godsend of Docker, what we use. We're going to go into a little bit of an exercise. We're going to code in microservice with Symfony. I'm going to do it live. It's going to be a little scary, so please don't boo. Let's look at our hypothetical situation here. We work at a company that specializes in storefronts. We're starting off, and we have 3 services right now. They're each running Docker, and they're doing what they need to do with their database themselves. We have one, it's the cart container, cart image. That's the one that's handling the user's shopping cart. People can pick and choose things put in their shopping cart. We have a catalog that's going to manage all the products that is available for us to sell. And we're going to have a storefront. The storefront is the thing that maybe you might look at the cart, and maybe look at the catalog and check them out, give them a price. But we kind of rushed it and we forgot one part. We forgot, oh, how are we going to manage the users? So the CEO comes up, okay, Lin, develop the user service. That's what we're going to try and develop right now. All right, the CEO didn't quite say how or how much users, so we're just going to say, all right, we're just going to have 2 endpoints in our web service that's going to run Docker over HTTP, and it's going to have one get to get the user, and a post, and you post that, and it's going to create a new user. So we give our estimate. Say it's going to take about 1 sprint worth of work. I hear some laughter. Estimates are real. So I'm going to, right now, switch over to live coding. So for those who want to code along, feel free to try that, but all right, let me just get this before I continue my thought. But there might be some things that, like typos or whatnot, we might save that towards the end. I have over here a cheat directory with kind of the finished product. There's a README that's going to show an overview of what I'm going to go through, and a scripts with helpful notes and whatnot to get us going through. So we're going to look at Docker from the first stage here. We're going to create a base Docker of which we will instantiate every single other container off. So with Docker, everything starts off with a Docker file. So the Docker file at the very top tells us that this is from PHP 7.2. That means it's instantiating from existing image. Think of it as object-oriented where a class extends. This is equivalent to that. Then I'm going to run a couple of other commands here. The run says run the command inside the image here. It's a Ubuntu-based Linux distro, so most of this is very Ubuntu, sort of Debian-centric. This is a Docker-specific command that installs the MySQL, that turns on mod rewrite, injects some custom configs that Symfony suggests that you install, and then adds it to the file. Then it does some janitorial work of making directories, and finally it exposes that directory as a volume so you can inject your own source code into there if you need to. This last line, expose, does what you probably think it does do. It exposes port 80 to the outside world, and that's what our Apache is going to run off of. So in order to build it, there is a command. What this does, it says, Docker, I'm going to build this command, and this -t says I'm going to tag it with that tag, and it's going to be referred to that with Docker. So let me go into this. And when you build it, since I have everything cached already, you might not, it's going to probably pull everything from external repos. So one thing to note here on Docker is you see these hashed there. Every single command creates sort of like a incremental snapshot of the image. So if anything changes along this line forward, it's going to use everything above it. So that's the cool thing about Docker. Well, that's great. We decided to use Docker for our application. Let's go off and create our user service. So this is a completely empty directory. I have something called template. It's just a bunch of helper scripts. I am going to copy those over, and then we're going to walk through what is in there. There's a couple of files here. We start off with a init. This just sets the project name for it. I'm going to run that first. I'm going to call it user-service. This here stores it inside a bash script so that everything else can export it and use it in the other scripts. The next step that we do is we actually run through setup. So I'm doing something a little bit interesting here. I don't have Docker, or I don't have Compose installed on my Mac because it's like version 5.1 of PHP, whereas this, I'm working with PHP version 7.2. Doing this will allow me to run Composer in its own container with all of its dependencies, and gives me access to the right version of PHP. So what you need to really note is that this is the actual Composer command. These are the Docker commands here. So I'm going to say Docker run -t-i means terminal output interactive input. And this is a volume mapping. It's saying mapping the current working directory, print working directory, into /app inside the Composer container. So the first command is fairly straightforward. It creates a skeleton project with the project name that I've assigned it, which is user service. These series of commands utilizes Symfony's bundle system. It's going to go off and look for these bundles and incorporate that inside inside its application. And then this Composer install, you can run this if you already have an existing project with all the dependencies defined. This will go off and install any dependencies that you may be missing. I commented out this because this here is going to be needed for the rest of the demo. What this does is it creates a virtual network inside your machine, inside your local host, and it's going to give it a name that's referenced by all the other Docker containers. So we're going to go ahead, and we're going to do a setup.sh. So this portion here might be a little slow. I hope it works. Any questions so far? Cool. So thankfully the network's working. It's getting this Symfony, I'm just going to talk you through this. It's getting the skeleton package. It's getting all the dependencies. So you might notice that there's like PSR2 cache, some things that I didn't define in the command. This is looking at other packages and installing the dependencies off of that. So it's going off and looking dependencies in dependencies. So it's recursively doing that. It gives you a little helpful thing on what you should do to, if you really wanted to, you could run the project with PHP's internal web network. We're not going to do that. We're going to go towards the light and use Docker. And now it's doing doctrine. The interesting thing about Symfony, if anyone has worked with the old Symfony, is that the new Symfony, the composer, JSON now, it uses make files to do most of this work. Before, it was kind of the scripts were built into it, but now it leverages make. I think there was a little bit of back and forth on that, but it seems to have worked out very well. All right, so it's just going through the last bits of install. You notice that this does take a little bit of time. Not something that you want to be doing very often. So what is it doing? Well, what it's doing is it's building out this structure for the project. And what it's doing when it says installing Doctrine ORM, Symfony ORM pack, all that, it's copying everything that it can download into a vendor directory. So this is how Composer manages things. So all of your code gets downloaded here, all of your external dependencies. So we're nearing to the end of this install process. I'll just move on to the next stage and just let that continue. We said that we're going to create this user service, and part of it was we're going to store the information. I'm going to be using MySQL to store that as a data store. We're going to use Docker for that too. We're not going to install it inside MySQL because you can download it using brew or whatnot, but we're just going to use Docker, so this will be the command that helps you do it. What this is doing again, it's Docker run. As you notice from the previous shell script, it's going to be using that name network, so this MySQL will be able to talk to our Symfony application because it's on the name network. This -p is the port mapping again, where I'm port mapping the standard MySQL 3306 port into the localhost 13306, so I can reference it and access it through there. --rm means remove the container after it's done for cleaning. Docker likes to leave it around after you finish it, but we don't want that to happen. This here, -name, gives it a name for the container. This name happens to also be the name at which the network will refer to the MySQL as. We can inject environment variables by doing the -e. This is not really recommended for obvious reasons, but for development reasons, this is good enough. -d means daemonize it, run it in the background, and we're going to run the container image MySQL 5.7. So, great, let's actually run it. There you go. You see it gives me a hash of some sort. That means it's running. You can also do that. The hash matches up. There's a container ID. MySQL's running, and the Docker PS is a good way to see what images are running. All right, we downloaded this application. We have it. Let's quickly walk through what Symfony has to offer. There's a bin directory. This is where all the console commands run from. Console commands are housekeeping commands that do certain tasks within Symfony. We're going to go through that a little later. Config is where all our configurations happen. This is, you can see here, all of our bundles of dependencies are stored there, how the routes and all the services are used. Public is the one single file. This is the entryway of the web application. This handles all the requests, and it does all the fancy routing through it. The source directory is the meat and potatoes of the application. We have the controller, empty. Oh, shoot. I'm in the wrong directory. I'm sorry. Here we go. So, exact same thing I was talking about. Controller is empty. Empty. So controller is where all the where all the controlling, I guess, happens in an MVC framework, so the model view controller. This is where the controller happens. The entities is the ORM representation of your database. That's one entity roughly represents one row inside your database. Migrations are where your SQL will sit that contain all your state changes in your database. So if you need to add a column, need to create a table, they go into there. And the repository is just a collection of ways to get at entities. We have nothing there since we won't actually need that at this moment. So we have a nice, clean, empty project. It's got the same var as I was talking about. Var is where all the caches and all the Symfony magic happens, the logs go by default. What I would like to do is start creating some stuff in there. Let's flesh it out. So what I'm going to do is I'm going to exec, which is execute a command inside a running container. Well, let's step a few steps back. Let's build the container first. And then we're going to run it. It's going to have nothing. It's going to be, oh. If you notice, inside the run directory, or inside the run script, I've commented out. There's multiple ways to run it. This is the most basic way, which is basically saying that I want to run it with port 8080 with nothing, and you can see something fancy. I will cancel out so it actually does something. So as you can see now, it's going to run on the same network that I've defined, tech demo. The rest you're aware of. It's mapping port 8080 to 80 input. And we're going to volume map our web app into the container. And this here is a little, we're going to volume map our credentials into there. This is how Docker Swarm, how Rancher injects credentials in it. So we're going to emulate that on our local. And finally, we're going to give it a name and tell the container to run. So there it is. It's running. One note for this, if you're working with this, you'll know that this will stop once you change the window. It's a weird byproduct of Debian, where it sends a SIG window change into Apache, and it doesn't know how to handle it. It dies. You can just remove the -ti so no signals go in, but for demo purposes, I'll just not change the windows. So I'm going to run it again. We're going to take a look at port 8080, and you will be greeted by the most beautiful site, which is the Symfony template, default template. All right, so we got something up. The next step is we're going to go back to here, and we're going to execute a command inside the container that is running. So the container was called user-service. And we're going to run bin bash. This will give me a shell script right into there. So I can PSAUX, see that Apache is running. I can go to the web app and see all my source code that is mapped here. Any changes I make in here, since it's mapped, it's going to affect the host. All right, let's work with some Symfony commands to help us create some code. We're going to use the console, and it provides us with a couple of neat utilities. The first one we're going to do is we're going to create the database. However, before we run the command, we'll need to set the credentials. So the way Symfony sets up the credentials by default with Dockerizing is it uses the DSN right in here. Not the best way to go about it, but we will use that for now and change it later. So the user was root, the password was secret, and the name of the host was tech.mysql. We're going to give it a database name, user to access. I did it in this .env file, but it also needs to be actually done in the dis file. What happens is The dist is actually the template that generates the .env for. You run a composer command to generate the env, which stands for the environment, and everything pulls from there. That happens in a Docker Compose. I'm not going to go through that step. It's pretty much just Docker Composer install, and it will generate that for me. We're going to skip that step. So the command to actually create a database, if all went well, if I put my credentials in properly, and if my SQL's still running, which I hope it is. So there we go. So what that did is it created a database called user. I'm going to have a little thing here. So there we go. Created a database user, nothing in it. All right, let's put something in it. So as I mentioned before, there's a migrations mechanism inside Symfony, and Doctrine allows us to just generate a migration for us. We're gonna, doc. Notice how when you do a typo, it does like kind of gives you some neat. Wait, what? Doctrine, right? Yeah, that's right. Okay. Thank you, Larissa. But now it's the crazy command. Oh, sorry. Okay, I'm going to get this right. Hang in there. So yeah, if you try to create the user, it's going to be like, yeah, it already exists. So it says here, I created a new migration. It gives it a file name based on like a timestamp, and it creates the file right there. So source migration. There's two methods, up and down. Up is for applying the migration, and down is for rolling back. So you have to create, or you could create if you wanted to, SQL statements to handle that. And how do you do that? Well, a method called add SQL. We're going to create it right here. Create table. Let me know if I'm typoing something, because I do that kind of thing. So I'm going to create a table with ID int. Let's make it auto increment, not null. Looks great. Our SRE team, our software reliability team would be really proud of me right now. I don't hear them laughing, so no. All right, so we're going to put primary key, and let's give it a unique key. All right, I wrote my first SQL. It's cool. So in order to actually put that into your database, you'll have to do something called a migrate. So I'm going to, after I generated it, I'm going to migrate it. It's going to go through, look at all my outstanding. Hopefully that SQL looks right? Okay, cool. All right, so lack of errors means it's good. It's going to go through, and it looks for all the outstanding migrations, runs it. Want to execute it, all good. There it is, my neat little table. All right, so what actually is the migration doing? It's a simple table that just stores all the outstanding. So if I try to run it again, nothing to migrate because it already saw that. All right, we got tables, we got a way to access MySQL. The next thing is we need to actually code some stuff to access the table. There's a cool little command inside the doctrine. If you look inside my script's notes, there's the way to import entities into your code base. What this does is it looks at your SQL create statements, and then it will generate code for you. I'm going to do that right now. I'm going going to run this command, cut and paste. And there we go. Let's see it. All right, so it created two classes for us. This one for each table. And as you can see, it kind of read through the create table sequence that you can get and built a class for us. It's got the integer ID, as I said, unique, the name, so everything as we expected. Questions so far? Cool. All right, as you noticed inside the code, it was just a series of fields. There's no way to access it. Another helpful command is to actually create getters and setters for those fields. We're just going to do that. Saves us some time with our brand new application. And there we go. We got the makings of a real application. Okay. There's no way for me to get at it from the web right now, so luckily, you can just go ahead and code in the controller inside here, but you can actually use a Docker command, or sorry, not Docker command, a Symfony command to help you generate it. I will be gentle, user controller. All right, let's open it up. So it created a brand new file here. User controller. Oh, this route thing looks interesting, /user. Let's see what happens if I go there. And that's exactly what the code says it would do. All right, let's create a couple of endpoints to do something useful. I'm going to hijack this bit of code here. I'm just going to call it, add user. Add user. We're going to add a user to the database. I also only want this to work with the post method. So if you do a get on it, it's not going to work. Post will. I also need to take parameters in from the request. So what I need to do is actually use the request object. Notice my ID right now, I'm using PHP Storm, auto-completed the one that I chose here, so we'll just put it in there. And I also need to have a way to put things into the database. Symfony Doctrine uses something called entity managers, but I will need the entity manager interface. That's how things work in this world. So what I'm doing here is putting in the parameters here, but Symfony is smart enough to know that if you put in entity manager interface, it's going to go off and inject the right dependencies for you. If you're interested, you can look at how that's done inside the config services YAML, but this really defines where all the files are in which to create a class from, an object from, and inject it in there. It looks at a match for entity manager interface and the namespace, and it generates it. So I think I have everything I need to create it. Let's create the user. Or actually, we need the name of the user. We're going to get it from the request, and let's go with name. The next thing we're going to do is just going to instantiate a new entity. New user, so that entity. And we're going to use set name, name. All right, that entity exists here. We are going to use the entity manager to actually save it. So the way we do that is we persist it in ORM fashion. And then flush means take everything inside that manager's store, turn it to SQL, and actually run the insert statement on there. So that is the makings of our application. I'm going to add a little helper method in here because I want to turn that into an array, not just, there's actually better ways to do this. There's serializers that will handle it, but it's a little bit beyond the scope of this. We're going to take the shortcut. I'm just going to return an array of this object. Name. Yell out if you see a typo. Okay. All right. We will then return this JSON. So this will turn that into a JSON object if everything works to array. All right. Very simple. Everything done in the controller, although you're not supposed to. It should probably be in a service class, but for demonstration purposes, good enough. Let's try and use this service. So I'm going to use Postman. Anyone know what Postman is? Everyone knows? Who here doesn't know? Yeah, everyone? Okay, cool. All right, I'm going to post, what was the endpoint again? /user, post. Name, achievers. Ha. All right. And there we go. We got a JSON back of that. I don't know, I can post another one. It has to be unique. It's going to throw an ugly exception. There we go. Auto increment works. So that's how we put the user into the database. We're going to create another method to actually get the user, get user by ID. Okay. We just do route. That is the right route. Yep, right class. We're going to say same path, sort of, but give it a parameter in there. Important note for Symfony annotations here. These names have to be different or it's going to conflict and you're going to wonder why things aren't working. And I'm going to say on the get method, put that into there. All right. I need that user ID, so I just put that in the parameter into there. Symfony does its magic and will insert the query string, or sorry, the path into that variable. I'm going to use the entity manager again, and then let's go about getting this object out. So to do that, we do get repo, get repository. Symfony manages all the repositories for all the entities by default, even though there's nothing in the repository. You can customize that to put your own methods to simplify some queries. You can put more advanced queries. I'm just going to do a very basic one. ID, user ID. So that is going to query, give me one result from the repository. It's going to turn that into SQL. And then it will turn it into a user object. I'm going to type hint this just because it looks nice. All right. I think I got everything. I'm going to return this JSON user just to array. Looks great. Everything looking good? Okay. Let's see if we can get something out of it. Pass in user 1, user 2. There we go. We have a fully functioning microservice inside Symfony inside Docker. I resized the window like I said I shouldn't have. But anyway, what I wanted to show you is that you can see what's happening inside the window here. It's handling the post command and it's turning it into a select statement. Get command. And yeah, handling select statements. Yeah, you can see the outputs into there. I probably killed the window. Everything's messed up. But we'll run it again. So my last two requests. So that get shows up. You can see everything in there like Apache could. So we built our microservice, and we went to the boss and said, hey, we're done after a month. We're going to deploy it. And he's going to say, how are the other people going to use it? And we say, well, Symfony has a feature called bundles. So we go off, and we create the API bundle for it. I've gone ahead and done that for us. And we define the behavior of our service in here. We say there's two things that we can do, get user, add user. We don't say how it's doing it, and this is available for use to any of the other clients that need to access our service. If we dig into it, it's simply a RESTful action, a get on the user by user ID, and then it just returns a model here. So the model is just simply a class representation. We have the same to array. Same with the add user. It does a post into there. So we have our current piece of software right now. We have the shopping cart, the store, and the catalog. The store itself will be the piece of code that's going to consume this service. So if we look inside there, we're going to see that there's a couple of services injected into this controller there. It's going to get the province from the query string if it's available. It's going to get the content of the cart. It's going to get the tax rate. It's going to get the products and the prices from there, and it's going to combine it out with an output in JSON format. So let's look what's actually in there. There's actually no entities, no migrations, no repository, so how is it managing to get all this? Well, it's using the other microservices that are available from bundle forms. So as we've created the user bundle, we've also created a tax bundle that will get injected into there. This is a piece of logic that is very simple. It just gives a tax rate. The catalog bundle is a little bit more similar to the user bundle in that we tell it to do something, and it goes off and fetches it the way it can. So we can do our logic based off of that. And it has a data representation, so the end user of this service has an easier time to work with it. So let's look at what is happening in the background there. We have Composer JSON. That's what the definition of the project mostly is. It contains all of our dependencies. So everything that I laid out in those composer commands, they're all in here. I've added a couple of repositories to point out where you can find the cart bundle, the catalog bundle, and the tax bundle. You don't have to just put a path here. You can actually put a Git repo or a zip file or, in my case, a path. And the symlink false just means that I'm going to copy it into my vendor directory rather than symlinking. So there's an option to symlink if you wanted to. So those are the inner workings of our product. We want to be able to change the dependencies of this so that it's going to be using our user service. So what I'm going to do is user bundle. And now this is saying, okay, this is where you can find the user bundle. It's a little bit cumbersome right now. Hopefully you have everything in a Git repo so that you just have to say, this is where all your bundles are in the Git repo. But for demonstration purposes, this is how it's going to work. The next step we need to do is run that composer command. There is a composer command that you can run. It's kind of a big jumbled mess, but what it does is it will import that command. So that require command that you saw earlier. A little trick that I did is use the Linux alias and just put an alias for dr. So I don't have to write this massive string out or even cut and paste. I just type dr and it will do it. So let's go into our store service. Dr. Oh, I should go into store service. No, I don't have to do that. So I will do dr composer. Oh wait, maybe sorry. I think I do have to do here. Dr composer require, and then achievers. We're going to go take a look at our user bundle here. Yeah, I'm going to copy and paste right from here. So in order to define the bundle, we give a name, a version, and this auto load. Those are really the most important part of here. If you don't have a version, Composer won't know what version to pick, and it's going to fail. This auto load gives it the namespace, so everything in the source directory has the namespace of user, so you can give a different namespace to your API package. So I'm running this command, it's going through and installing the bundle, hopefully. Yep, it's found the version that it needed. It's found a version. Is there any questions right now, or no questions? Okay. All right. Am I in the right directory? Oh, no, not done yet. Store service. So there it is, user bundle. I'm not sure why this is not refreshing, but yeah, it's a weird IDE thing. Oh, okay, there it is. So now I have everything in there. I also need to configure that bundle so that I can actually program with it. Anything that's out of the namespace of this application, it's not going to be found by the regex that's over here in terms of building those services automatically. So we're going to have to, we can either change the regex or just manually put the service in there. And the URL is simply user service. All right. We can, so you notice over here that we have a whole bunch of different microservices. And I ran the user service by itself and the MySQL by itself. I can go through the process and actually do the same and bring them all up on the same network. So I would go through and start up the user, the shopping cart service, the store service, and the catalog service. And I'd have to go through and run each one of them individually. Who here wants me to see me do that? No, okay. Thought so. Luckily, there's a solution to that. I'll get to that a little later. But for kicks, maybe I should do that now. We're going to start using our user service by simply doing user service. And it imported the right one. Don't have to worry about my PHP docs just yet. So we're going to get the user ID from that. And the user ID, or user model, it's going to return a model as per described inside our bundle. And let's just put name inside here. user model name. All right, so that's really what the boss asked for us to do, and I think he's going to be happy with us. But I'm not going to run through and run every single command or every single image up. I'm going to do it with something called Docker Compose. Who here knows what Docker Compose is? Okay, not including my team. All right, cool. Well, Docker Compose is a way to string all your dependencies together in a Docker with all the Docker containers. So inside the Compose directory, you'll see there's a bunch of things in there. The most important thing is Docker Compose.yaml. Let me just do some housekeeping here. I'm going to stop the MySQL. So I'll show you how to do that. Stop tech MySQL. All right. We're almost to the end. Everything's stopped there. All right, so let's take a look at the Docker Compose here. At the first level here, we got versions and services. That's pretty standard. Then we define, given a name for each one of our services. So the proxy service is over here, and there's a comment on the catalog service on what each element means. The container name is the name we give the container, obviously. It's the name of which it will be referenced by inside the internal network as well, so you can access it through the URL with catalog service. Build is the command that helps build those images, and we inject some arguments inside those Docker files. So each one of them, it uses pretty much the same Docker file. We just provided a different argument into there. We give it a different, an image name. This is something that you can use when you actually deploy it into a production environment. And volumes, again, we're going to inject our credentials from here into the container. And we have one for the shopping cart, the store, and MySQL. You'll notice over here, you can also map independently different volumes. I mapped a volume for the data for MySQL so that every time you shut down the container, what usually happens, everything inside there evaporates, it's gone. So that MySQL image that I ran with all that data, everything's gone in it. What you can do is you can map volumes, and it will persist that because it's shared on the local. So that's why I'm mapping over here. And obviously our source code gets mapped in here. But I'm giving it port 13306 for that, and port 8080. And now you'll notice there's no user service. So let's put the user service in there. Container name, user service. Let's tell it to build. Let me know if I typo, because I do that stuff. As you notice, my PHP Storm is pretty awesome. It just does like 90% of the work for me. User service. If you want to know what plugins and everything that I'm running, come talk to me at the end. There's a whole bunch of value or quality of life things that plugins provide. All right. So we got a user service, we got a catalog service, and you might have noticed we have a proxy. So the proxy is taking everything from port 8080, and it's the machine that sits in front of all of them and handles all the requests for us and divvies up where everything goes. You can, if you're familiar with HA proxy, or if you're not, what this is doing is anything with a /s or /t, it goes into the store, goes into the catalog, goes into the cart. You can trust me that that's what that does. We're going to bring this up and see the end result. Okay. Docker Compose. How do I bring things up? Docker Compose up. So since there's no volume mapping to the source code, I'm going to have to actually build each one of those containers for myself. I think the store container was the one that was changed. So let's do a build on that. And I think I already built the user container, but just in case. We're going to give brand new builds onto there. Just in case. It's always good to build. So it's going to go through, look at all the dependencies, and it's going to start bringing up each one of those containers as a whole, all together. It sure beats going through manually and running, turning them on, and then turning them off individually, especially in a development environment. All right. Bring up MySQL, bring up the store. I think the proxy's already up. No, the proxy just came up. Everything's working, I hope. And when you do a Docker PS, you can see what it's running and what version everything's going off of. Okay, so as you notice, port 8080 was exposed. If you look at the documents, there's an endpoint here, cart value. And there we go. We're pulling in our name, and we have everything else that came in with it from the user service. And because of the mapping, we can actually hit, I think, S for store. We can hit it directly without going to port 8080. So it's using that proxy. So that is the demo portion of it. Let me jump back into the slides. All right, questions? So we ended up building exactly what we set out to build, and we came across a couple of challenges. I'm just going to step through them. So the first challenge is keeping the code and container in sync. There's a couple of ways to do that, because when you're working with Docker, when you add code inside the container, that code is static. That means whatever you're working on inside the container, you have to do a rebuild every time you want to see those changes. That is what's happening on the right-hand side. On the left-hand side is what we want to do in the development environment. We want to volume map the code inside the container. So not a static piece of code is in there. It's going to accept all the changes that you have inside your code base. So in order to volume map, you can do it in the Docker Compose. Simply do volumes, your local directory, to your your container directory. And we've already seen Docker run what that looks like. You can volume map the local inside the container. Helps a lot. However, when you deploy, you don't want to volume map to something that could possibly be dynamic. You'll want to embed that code in there. So your code at the top, you might do something like git pull from the archive. It'll give you a tarball. You'll push that tarball into the container, and that will be static. So that helps with the container code. Deploying the code, you'll notice that Composer, oh, sorry, question in the back. Question? The demo was a completely Dockerized container. So we ran another, at the very beginning, I think I showed you the run, and it sprung up a complete Docker, containerized image of it. And if you look inside the Composer, there's a section that defines MySQL, and that also runs in container. There's no MySQL running on my local. It's all within containers. So there's two ways. When I was running at the very beginning, that was all inside the container. That was not mapped anywhere. That meant if the container was gone, the data's gone. Inside the Docker Compose, I did a volume mapping from var lib MySQL into a data directory on my actual machine. That meant if the container goes on, the data files are still there. And then when it comes up, it sees the data file again, and it operates as if it was persistent. The reason why everything works so fast on the Docker Compose and I didn't have to do all that is because that data was persistent. That data already existed. I already populated the shopping cart and everything beforehand. So getting back to deploying code, when we're deploying code, you'll notice it was a really long time to do a Composer install. That's something you'll want to do during the build process when you're pushing it out to production. Don't put that inside your Docker file. It's just going to take long. And the reason why is your container startup time is going to be forever. You're not going to have static code because every single Composer install, you might get different versions or just different libraries. So you don't want to start up a container like, oh, I don't quite know what's in there. And obviously, the more you're downloading, there's going to be some network pull off of that. You want to reduce that on every time you restart a container. That's not something you want to happen. What it generally looks like is you'll get your source code, you'll run a Composer install in a compatible container, it'll pump out a vendor directory. You can push that into a build process and copy that into your image, and then that image will have the static version of the vendor file. And that's something we do here. There are certain things that we do want to run on runtime. You'll notice those creating the migrations or running the migrations is something that happens inside the container. It's not really dependent of the content in the containers, the external. You can offload that into a startup script. So every time it starts up, maybe you have a flag that says, we're going to run migrations. So that takes care of that. Then configuration settings. A lot of the, oh, I skipped to this part. No, I didn't. The database, we stored it inside the DSN. That's not something we want to do because you ended up storing your credentials inside inside your code base. That's not something you want to do. What you can do inside Docker is inject the actual variables into there so that you're pulling it from the environment variables and not inside the code base. And when you're storing credentials as well, you don't want to store it inside your code base for obvious reasons. There's mechanisms inside Symfony that allows you to actually read those files from, or read those credentials from a file and then inject it into the settings. That way, you just have to change your credentials in your Docker manager. It will be reflected in there without any code changes. I think I did skip through that, but it's inside the demo if you're interested. Orchestrating different containers. We use Docker Compose because obviously going through and then Docker up, Docker up, Docker up, or Docker run, whatever it is, doing all the volume mapping for every single different service is a pain in the butt. You can use Docker Compose to put that all together and bring it all up in one shot on your local. We use Rancher here. There's a similar thing called Rancher Compose, and it uses Docker Compose as well. We just have the definitions in there, and it will bring up all the containers for us as well. And finally, service reuse. So we built all these microservices. What's an easy way to share it inside the Symfony environment? We use those bundles. Those bundles can be accessed by any of those different services. The user bundle could have been used by the cart service if it needed to, and then it could have just used that interface to access the intricacies of the user service from within there. So those were what we worked through when we developed this application with Symfony and Docker. Most of the steps are pretty much the exact same thought process that we came along when we developed it. All the stumbling blocks pretty much laid out in that demo right there. A couple of things that we didn't talk about was how do we debug and what does that look like. Usually, there's really no way around it. There's going to be two different containers for debug versus production. We keep them as similar as possible. You can use different switches to install certain things in different environments, but you're going to end up with two different images. The development one will have Xdebug, will have Composer possibly, will have all your different profilers in there. You don't want any of that inside your development one whatsoever. You can, however, simulate a production deployment by using a Docker Compose, and it will run your production images as they would be on your local. You just have to put in different environment variables to point to different databases and whatnot. Unit tests, we didn't go through unit tests, but it's the exact same scenario. You'll definitely want to volume map your source code so you're not having to rebuild the container every time you do a unit test. You just want to be able to refresh, see the unit test, and you're going to have a different container for that as well, because there's going to be PHP unit, Xdebug that's going to sit specifically in that. You don't want that in production. And one of the things we do strive for is that production container. We use one container for all the deployable environments. So that container at the end of the day, that's not the development one, can sit on QA, can sit on your staging, or can sit on your production. Exact same container. You pipe in different environment variables or different credentials, and it should work as expected from that. You'll have the same code across that, and you'd be confident in doing that. So that's my talk. Any questions? Question there? There's definitely going to be a delay. If they're sitting on the same network, for example, you're on the same Docker post, it's going to be very minimal. However, there's always going to be an overhead because it's not talking directly through it. It's going to be, it's going to go through Apache first off, and it's going to go through the whole marshalling of the JSON script and whatnot. But network-wise, because it's literally on the same subnetwork, it's quick on that way. It's not like it's fetching it off the internet for that. It could, there will be a delay if you did it that way, but in our use case, there's not much. Okay. All right. No more questions? All right, thank you for coming out to Tech Talks. I think, Larissa, you were going to say any closing remarks?
Thank you guys so much for coming out. We really appreciate it and happy to see you here. We hope that you enjoyed the talk, and more importantly, that you took something away from it. If you like our content, please follow our blog at tech.achievers.com on Medium, and we hope to see you at our future meetups. Thank you so much.